Hello and welcome back. This video will cover section 1.5 again, but it will be on modeling equations of circles. So what I've done here is there are a couple applications in the book about Ferris wheels. I've looked up a Ferris wheel in California at California Adventures. It gave the dimensions of the Ferris wheel, and we're going to use those dimensions to model an equation and answer some questions about the Ferris wheel itself. So this one has a diameter of 150 feet. That means that the radius of the Ferris wheel would be 75. So radius equals 75 feet. Okay, and so I have drawn a picture of what the side of the wheel might look like and put it on a grid so that we can try and figure out what the equation would be if we're looking for distance, or if the gondola is on the outside, we want to know that those distances out. It looks like they have movable gondolas inside this, but we're going to take a look at the outside gondolas and how far they are away from the ground as an application. So I've drawn this on a grid. And since the height is 160, that means that it's 160 at the top. That means 150 is the diameter, but we have 10 feet here that's above the ground. Each of these grids are 10 feet on what I've drawn here. So let's use this information to help us find an equation. So the equation that we're going to use is for a circle, so it's going to be x squared or x minus h squared plus y minus k squared equals r squared. So that's going to be our equation of the circle. We have the radius is 75, so that means we know this number right here. We know this. And looking at what I've drawn here, we should be able to figure out the center that's along this axis here. So I've centered the axis in the middle so that we can do that. You could put the axis anywhere, but I'm thinking it'll be easier for me to evaluate if I put the axis in the center of the circle. So that's what I've done. So here's my x-axis here, and here's my y-axis here, and I've centered the circle around that point. So if we know it's 10 feet above and that then it's 75 for the radius, that means that we should end up at 85 along the y-axis for the center. So we have 10, 20, 30, 40, 50, 60, 70, 85. So the center should be right around this point on the graph. So my center of the thing should be 0, 85, because we put the axis right there. So that should be our center. So that means that our equation should be easy to fill in. We have the center point, so we have h and we have k. We'll also have r because we know the radius is half the diameter. So our equation for this model would be x squared minus, it would be x minus 0 squared, which is just x squared, plus y minus 85 squared equals 75 squared. Okay, so that would be my model that I would use in answering any questions. X is my horizontal distance. The distance going this way is x, and my vertical distance is y. So what we're going to try to do is answer this question right here, which is if you were to walk 40 feet from the base of the Ferris wheel and look up to see two gondolas above you, how far would they be? How far above you would they be? So that means if I were to walk out, that means looking at this picture again, I'd walk out 40 feet, so that's from here, here's 20, 40 feet. If I'm standing right here in my picture, how far above this would be these two gondolas if they sat here? If there's a gondola here, and then there's a gondola right here, how far above you would those two gondolas be? All right, and we can estimate using the graph. It looks like this one's a little more than 20, approximately 20 plus, so a little more than 20. And this one here is 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, right around 140, maybe 100, approximately 145. 145. So counting up, I'm thinking that that's how many feet this is. So about a little more than 100, a little more than 20, and a little more than 145. So let's just verify that. Let's try to use the algebraic equation. Let's use this equation right here to try to compute those values. So what we know here is that we've walked out 40 feet. So 40 happens to be my x value. So I know this value here is 40. So I'm going to use that to plug my equation in and just solve my equation for y. So I'm going to start out with the equation, but I'm going to put 40 in for x, because that's how far we walked out horizontally. So you're going to get 40 squared plus y minus 85 squared equals 75 squared. So if I take my calculator and compute these two values, this is going to be 1600 and 75 squared is 5625, 5,625. Okay, so I'm going to subtract 1600 from this, and I'll get 4,025 equals y minus 85 squared. Now I have two ways I can do this now. I can take and do FOIL with this, multiply this out, which would give me a quadratic, and then I would have to probably use a quadratic formula to find the answer. But we could probably just solve this pretty readily by taking the square root of both sides. So if we take the square root of this side, it should get rid of the square, and if we take the square root of this side, we should get two values, because when we take the square root, it's a plus or minus value. Okay, so it's a plus or minus value here in the square root. So we're going to end up with y minus 85 equals plus or minus 63.44, I believe. Let's just double check that. Square root. Okay. Calculator seems to be frozen for a minute. Square root of 4025. I just want to make sure I have that. Okay, so yes, 63.44. 63.44. All right, so what you want to do then is add 85 to both of these values. So you're going to get y equals 85 plus 63.44. And y equals 85 plus, or 85 minus, because it's plus or minus, 85 minus 63.44. So if you add and subtract that from 85, you're going to find out, you'll get close to the values of, for the first one here, I get 148.4. Or on the second one, I get a positive 21.6, rounded to one decimal place, 21.6. Now, so that's telling me that the two gondolas are going to be 21.6 feet up and 148.4 feet up, which is what we got by looking approximately at the graph. You can see that the graph's pretty accurate and that we got similar answers using algebra. So that's an application that we can use. We would use the circle formula and we would model this circle with a circle equation. Now it's important that you realize that this is not the only circle equation we can use, depending on where we put the y-axis. With the y-axis I put in the center. You could also run the y-axis over here somewhere and you'd have a different x value, but it would still give you the same heights. It's just helpful in this, since we're walking from the base, that we use that as 0 so that we can plug 40 feet in to our equation. So that is our solutions in feet. And if you have any questions about that or any applications you might run into, give me an email and we'll move on to the next step on our next video.